So for this second question, deduce the electron configurations of the cobalt 2 plus ions. So to deduce the electron configurations, we need the atomic number of the neutral atom first. So we can see from the booklet, on booklet 7, in the periodic table, it shows that the atomic number is on top one here. It shows that the cobalt has 27. So if we going to do the neutral one first, 27. So how do we actually do the electron configurations? It's basically based on, there's this chart. Usually how do you do it is that you can put a 2s2, 2p6, 3s2, 3p6, this diagram, for S2. So it need to be filled diagonally. So we start from 1s2. So if we have 27, means that we added 2 by we keep adding it. 1s2 means there's already 2 electron, then 2s2, 2p6, then it goes to, after you have 2p6, you go to 3s2. This is the total is already 10, then 12, then put another 3p6, it become 10, 12, 18. So we are left with 9 more. So before we fill in the 3D, remember it's diagonal. So you from 3p here, you need to go for 4s first. 4s2, 4s2, then 3D, because it's left with, so 2 plus 2 plus 6 is already 10, 12, 18, 20, and it left with another 7. Okay, this is the electron configuration when it is at the neutral state. But then because the one that is asking is 2 plus, mean you need to remove the 2 electron. So although you're filling it in like this, the one that you need to remove is always the outer electron, which is the 4s2. The outer electron is the 4th layer, which is the 4s2. So if you remove the 2 electron here, the CO2 plus electron configurations. So although you are filling in 4s first, then 3D, but then when you're taking it out, always taking it out from the largest number, the largest cell. 2 plus become become 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d7. So this is the electronic configurations of cobalt 2 plus. Then for the next question, there we show that there is an equilibrium. Okay, when hydrated cobalt ions are mixed with the concentrated hydrochloric acid to form this COCl4 2-. Predict the effect on the value of K and equilibrium position when solid sodium chloride is added to the mixture at constant temperature. So when it said that it added the solid sodium chloride in the liquid, so this sodium chloride can break into Na plus and Cl minus. This Cl minus could affect the equilibrium shifts. But then, does it affect the K? No. So equilibrium constant is always the same if it's the constant temperature. It will only change. So K So equilibrium constant has no change because it has a constant temperature. Because constant, okay, because it is constant temperature. How about the equilibrium position? The equilibrium position will change. So because there's a Cl minus here that actually added in the left side, so to make all the equilibrium stable back, it will shift to the right side. So if you all remember the Le Chatelier principle, so if you add concentration on the left side, it will try to balance it and by moving it to the product side. So the equilibrium position will shift to the right. Okay, then after that we go for number 2. Heating equilibrium mixture that initially is pink changes the color to purplish or blue. So decide whether this formation is an exothermic or endothermic. Okay, so we can see it's initially from pink, but then mostly now it become blue. And now it become blue. Means that it favors toward the product side when it heats up. So again, based on the Le Chatelier principle, is that you want to oppose everything that you put in to make sure that it goes back to the equilibrium. So when you heat it up, you're basically increasing the temperature. So to balance this, you are going to absorb the energy so that the heat will be reduced. So absorb energy is a endothermic. So you want to absorb the heat, and absorbing the heat is basically an endothermic process. It's an endothermic process, and because it's stated that when heating it going to the blue side, means the directions from the reactant here to the product is to the reactant to the product is endothermic reaction. So deduce and giving a reason whether the formation of this COCl form is an exothermic or endothermic, you should say that is a endothermic reaction. So basically you can type in that is a endothermic reaction. The reason is because it favors the product side when the heat increase, when you apply the heat increase, the temperature or the heat, when there's a heat, or you can say the temperature increase. So this will be the answer. You can write down this answer.